The Big Bang Theory is known as the best concept about the origins of the universe. Today, astrophysics has shown that the theory accurately matches the phenomena observed in the universe for centuries. It is a solid foundation that helps us understand how the universe formed 13.7 billion years ago. It all began with the Big Bang Theory, and it holds that everything came to life all at once. The problem is that everything before the Big Bang is impossible to understand. However, popular science publications on the James Webb Telescope photographs claim that the Big Bang never happened, thus generating panic among cosmologists. How do these images suggest the inaccuracy of the Big Bang Theory? Let's decipher the evidence presented by the telescope itself to clear up any doubts. The potential benefits of the James Webb Space Telescope far outweigh the risks associated with this launch. No other scientific instrument has held so much promise for advancing our understanding of the cosmos, so scientists around the world have been eagerly awaiting their turn to use this telescope since it was declared operational. What none of them expected were such shocking discoveries. In less than 2 months of being operational, the James Webb Space Telescope has already captured images that contradict the Big Bang Theory. The understanding that the universe was born with a Big Bang is intrinsically ingrained in the imagination of millions of human beings. However, this theory is not as solid as most people believe. Many scientists, including atheists and naturalists, recognize that the theory has serious flaws, and the latest photographs provided by the James Webb Space Telescope have not perplexed those who firmly believe in the Big Bang Theory. The Big Bang Theory grew out of the work of George Lemaître, a priest-turned-astronomer who in 1927 proposed that the universe began as a single point. He claimed that the entire universe had expanded to its present size and could do so forever. A few years later, astronomers Edwin Hubble, after whom the Hubble Space Telescope is named, improved on Lemaître's theory. Hubble revealed that other galaxies were moving away from us, and that distant galaxies were moving faster than nearby galaxies. Consequently, the astronomer concluded that the universe was still expanding, such as Lemaître predicted. If everything was moving away, it meant that everything was close together before. According to the Big Bang Theory, the cosmos originated as a collection of tiny hot particles intermingled with light and energy. As energy grew and took more space, the temperature dropped. The tiny particles clumped together to form atoms, which in turn clumped together to form the stars and galaxies we see today. These early stars produced larger atoms and atomic clumps, and new stars were born. Galaxies collided and merged together, creating an incredible cosmic spectacle. Other objects such as asteroids, comets, planets, and black holes arose as new stars formed and perished. All this happened over the course of 14 billion years. But what if the Big Bang didn't happen? Most scientists don't want to explore this idea because it has been a cornerstone of modern astronomy. But the James Webb Space Telescope has generated a bit of chaos with its recent photographs. Right now, cosmologists all over the world are trying to explain why the James Webb Telescope images don't match the Big Bang Theory. The James Webb is meant to look at the infrared wavelengths of the electromagnetic spectrum, since light from very distant galaxies passes into this region of the spectrum. Our legendary telescope should be able to capture more detailed pictures of these galaxies. According to the Big Bang Theory, the light emitted by the most distant galaxies took more than 13 billion years to reach the Earth. And according to this famous theory, we should see these incredibly distant galaxies not as they are now, but as they were more than 13 billion years ago. As a result, we should see the galaxies in their formation process, even when they were not evolved. However, this expectation is often challenged, and preliminary tests from the James Webb confirm the pattern. Initially, results from the James Webb Space Telescope seem to imply that large, bright galaxies developed before the alleged Big Bang. If proven, this will radically challenge current cosmological beliefs. Many of these galaxies appear to be more massive than the traditional cosmological model, which defies the composition and development of the universe. To be fair, these are only preliminary results that have not yet been validated, but they are clearly generating anxiety among Big Bang theorists. I am slightly concerned that we will find these galaxies in the James Webb images, said cosmologist Richard Ellis. The images shown by the James Webb Telescope have a flaw. They show an unusually large number of smooth, compact, and ancient galaxies. This seems to contradict the Big Bang theory. But why? Consider a very narrow point of view. If the cosmos is expanding, we are seeing a strange optical illusion. In reality, galaxies and other naturally occurring space objects do not appear to decrease in apparent size as one moves away from them. They should increase in size exponentially above a certain threshold. Think about this. Galaxies get closer as one moves away from the visible brightness. This contrasts with how things look in unexpanded space, where distance has the opposite effect and objects appear smaller as they get farther away. There's no denying that scientists who have analyzed the Webb images have discovered small galaxies. When compared to the Hubble images, galaxies with a brightness and mass greater than that of the Milky Way appear to be 2 or 3 times smaller in these images. This kind of activity from an expanding universe is quite unexpected. If the universe is not expanding, the galaxies observed by the JWST are the same size as the galaxy closest to us, and the redshift is proportional to the distance. According to the Big Bang hypothesis, these very distant galaxies must be, in essence, unusually smaller to explain the supposed optical illusion. This strange observation challenges our current conceptions of the evolution and structure of the universe. If distant galaxies appear to be considerably smaller than expected, it opens up a new field of study in cosmology. Scientists are now engaged in heated debates about the possible implication of this unexpected phenomena. Some theorists suggest that this apparent discrepancy in galaxy size could indicate variability in the fundamental laws of physics on cosmic scales, raising questions about the accuracy of our current models. Others propose that there may be unknown factors or phenomena not yet understood that could explain this apparent decrease in size of distant galaxies observed by the JWST. The possibility that our theories about the expansion of the universe and the evolution of galaxies are incomplete or wrong has ignited fervent interest in the scientific community. The James Webb Space Telescope mission has become a beacon illuminating the deepest mysteries of the cosmos, challenging us to re-examine and reframe our fundamental understandings of how the universe works. In the meantime, astronomers continue to meticulously analyze the JWST data in search of more evidence to shed light on this cosmic enigma, hoping that these discoveries will bring us one step closer to understanding the true nature and evolution of the universe we inhabit. The James Webb Space Telescope has transformed our view of the universe. The images obtained by this large infrared-capable telescope have caused a sensation around the globe and have been shared on a massive scale. It is safe to say that the James Webb is the most advanced telescope in the history of humankind. So far, the scientific observations made by the James Webb Space Telescope have been invaluable and fully justify the $10 billion invested in its construction. The first images from the telescope were released to the world on July 12, 2022, and experts believe they showed that James Webb is at its best and fully prepared to continue uncovering the secrets of the infrared universe. These images include the cosmic clefts in the Carina Nebula, the exoplanet WSP-96b, the South Ring Nebula, Stephanie's Quintet, and the stunning deep field view of the universe, although these were only the first images. Since then, the James Webb Telescope has provided scientists with even more spectacular and stunning images of the cosmos. Some of these images have perplexed astronomers and cosmologists. and have led to the publication of many astronomical articles. However, some of these papers have generated some panic among cosmologists because they seem to directly contradict the Big Bang theory. If you're interested in keeping up to date with news from the universe and its surroundings, subscribe to our channel. Be sure to like this video and turn on the notification bell. To better understand what is going on, it is necessary to first understand what exactly the Big Bang theory is. The Big Bang is the predominant cosmological model that explains the evolution of the observable universe. It was developed from observations of the structure of the universe and theoretical considerations, and explains how the universe expanded from an initial state of high density and temperature. The Big Bang theory describes an increasingly concentrated universe originating from a singularity in which space and time lose their conventional meaning. Based on detailed measurements of the expansion rate of the universe, the Big Bang singularity is estimated to have occurred about 13.787, more or less 0.02 billion years ago, which is also approximately the age of the universe. Although the concept of the Big Bang may seem confusing, it is actually quite simple. The universe is continuously expanding, and the name Big Bang can be misleading, as it suggests that there was an explosion at a particular time and place with a center. However, the universe has no definite center, and the Big Bang occurred everywhere at the same time. This process occurred over time, not a specific point, and galaxies are moving away from each other without a definite center. Although we cannot directly observe the Big Bang, there is observable evidence for it. For example, the heat that was generated about 380,000 years after the Big Bang can be detected throughout the universe, which has been mapped by satellites such as the Carnot Background Explorer, World Ends Microwave Anisotropy Probe and Planck. During this period, the universe was very smooth and simple, with small temperature ripples. The James Webb Space Telescope, designed to image the first object that formed as the universe began to cool after the Big Bang, has seen further than the Cosmic Background Explorer Telescope or Professor Michael Webb and Professor Blanco's story. Dr. Mather, who is the lead scientist of the James Webb Telescope project, claims that this telescope could image objects that formed hundreds of millions of years after the time period that other satellites were built to see. The small changes in temperature observed by those satellites may have been the seeds that eventually became new galaxies. Although we do not know exactly how and when the first stars and galaxies formed in the universe, the James Webb Telescope was built for the purpose of answering this question. In summary, the Big Bang theory is the primary explanation of how the universe began. This theory indicates that the universe began as a hot, dense point that inflated and stretched at initially unimaginable speeds, and then at a measurable rate. Over the past 13.8 billion years from the Big Bang to the expanding universe we see today, the Big Bang theory has been widely accepted as the most likely explanation for the origins of the universe. However, new images from the James Webb Telescope are causing some uncertainty among some scientists about the credibility of this theory. Most cosmology theorists have defended the Big Bang theory as unquestioned truth for decades. But new data from the telescope are causing some people, like Alison Paltic, an astronomer at the University of Kansas in Lawrence, to question everything they have done in this field. The extremely small, smooth, ancient, and surprisingly numerous galaxies observed are completely incompatible with the Big Bang hypothesis. In the view of some scientists, the Big Bang proposes that the universe is expanding, and that galaxies and other objects in expanding space should appear larger with increasing distance. However, images from the James Webb Telescope shows us more and more smaller galaxies, even those with a luminosity and mass much greater than that of the Milky Way, suggesting that the universe is not expanding and that the redshift is proportional to the distance of galaxies. In other words, the galaxies shown by the James Webb Telescope are the same size as the galaxies near us, indicating that the universe is not expanding. The images obtained show that the galaxies have a redshift that is 2 to 3 times larger than expected according to the theory of an expanding universe, which contradicts this theory but aligns with the prediction of a non-expanding universe. Previous results based on Hubble Space Telescope images showed a redshift of up to 5, which agreed with expectations of an ordinary non-expanding space.
Big Bang proponents expected to see galaxies chaotic and destroyed by collisions and mergers, but the James Webb Telescope images show smooth disks and ordered spiral shapes similar to present-day galaxies. According to Eric Lerner and Ricardo Scarpa, these findings challenge the theory of an expanding universe. The data in the panic paper indicate that there are many more smooth spiral galaxies than expected, challenging the idea that galaxies have a common formation process. Lerner and Scarpa argue that these data completely discredit the theory of galaxy formation. Furthermore, the Big Bang theory suggests that the most distant galaxies in the James Webb Telescope images look as they did 400 to 500 million years after the origin of the universe. But some of these galaxies have stellar populations that are at least a billion years old. According to the Big Bang theory, nothing could have originated before, which leads to the author of Panic to believe that the existence of these galaxies is proof that the Big Bang did not occur. In a study to be published in April in Monthly Notices of the Royal Astronomical Society, the researchers analyzed in detail a cluster of nearly extinct stars of enormous antiquity called HB1. The extraordinary cluster lies about 21,500 light-years from Earth, in the central bulge of stars at the center of the Milky Way. They are true fossils that revealed what the early days of the universe were like. First generations of stars formed when the only available material was hydrogen and whose age rivals that of the universe that contains them. And now, to the general surprise, a team of astronomers has found some of them within our galaxy. To observe it, it has been necessary to combine the power of two large telescopes, Gemini South in Chile and the Webb Space Telescope. Thanks to the sum of their data, the researchers were able to calculate the age of the stars in the cluster, which turned out to be 12.8 billion years old, which includes them in the group of the oldest ever found in both our galaxy and in the universe in general. This cluster of stars, says Stefano Sousa, co-author of the research, is like an ancient fossil buried deep in the central bulge of our galaxy, and we have now been able to date it to a distant time when the universe was still very young. These are also some of the oldest stars we've seen anywhere else.
Thanks to the groundbreaking and revolutionary James Webb Space Telescope, we are about to unveil 5 stunning new images that redefine the boundaries of space exploration. Get ready, because the universe is much more intriguing since the James Webb is sending us images. Remember to like the video and subscribe if you're not already. We start with the enigmatic galaxy ANGC 548. In the vastness of the cosmos, we often observe galaxies that follow recognizable patterns. However, have you ever come across one that breaks from the norm? This is where the ANGC 548 galaxy comes in, a galaxy that refuses to fit the typical descriptions. ANGC 548, located in the constellation Centaurus, was initially cataloged as a planetary nebula by English polymath John Herschel in June 1834. But there was a twist in the tale. For a long time, astronomers considered it a planetary nebula, which is essentially a glowing envelope of gas and dust created by an ancient dying star. However, ANGC 548 later revealed its true identity as an irregular galaxy located approximately 16 million light-years from our planet. If you're wondering what a light-year is, it is the distance light travels in 1 year. So, when we say that ANGC 548 is 16 million light-years away, we imagine the vastness of space that light has had to cross for 16 million years to get from ANGC 548 to Earth. ANGC 548 harbors a mysterious entity called ANGC 548X1, which is no ordinary celestial object. It is an ultra-luminous X-ray object, which could be compared to a cosmic lighthouse emitting a massive X-ray burst. These sources are incredibly rare and intriguing to scientists, and astrophysicists speculate that they may hide intermediate mass black holes. With the unique shape of ANGC 548 and its possible connection to intermediate mass black holes, it is not surprising that this galaxy has puzzled and fascinated astronomers for nearly 2 centuries. It is a true cosmic rebel that challenges our understanding and invites us to explore the wondrous mysteries of the vast universe. Image number 2. The glowing core of NGC 2217. The glowing heart of NGC 2217 is a celestial enigma that immerses us in the wonders of space. This galaxy is nestled in the constellation Canis Major, a staggering 65 million light years from Earth. To put it in perspective, the light we are seeing today began its journey at a time when the dinosaurs roamed our planet. NGC 2217 is no ordinary galaxy. It is a barred spiral galaxy. When we speak of a bar in this context, we do not mean a long straight object made of metal or wood, but a structure formed by countless densely packed stars that emit light, creating a bright central band. This galaxy is comparable in size to our own Milky Way galaxy, stretching approximately 100,000 light years from one end to the other. Imagine undertaking a journey across such an expanse. It would be a journey that will take a long time. So why is this central bar in NGC 2217 relevant? Well, in galaxies like this one, the bar acts as a sort of conveyor belt that guides and funnels gas from the outer regions of the disk into the galaxy's core. Once there, the gas and dust have two main fates. Some coalesces under the influence of gravity to give rise to new stars, further enriching the galaxy's stellar population. Meanwhile, others have a different fate. They are attracted by the giant lurking at the center of the galaxy, a supermassive black hole. In the grand scheme of the universe, NGC 2217 represents a shining example of how galaxies evolve and transform, driven by their internal dynamics and the colossal forces at work in their cores. This glowing core is a mesmerizing reminder of the complex dance of stars, gas, and dust that unfolds millions of years away but interwoven into the vast tapestry of the cosmos. Image number 3. Luminous stars in the cosmic weave. Imagine pouring a pinch of salt onto a dark canvas, where each grain glows with its own light. This is the stunning visual display provided by NGC 1755, an open star cluster that unfolds before our eyes through the lens of the James Webb Space Telescope. This dazzling cluster is anchored in the constellation of El Dorado. With its deep gaze, the James Webb Space Telescope has delved into the heart of NGC 1755 with the goal of unraveling the intriguing mystery of the coexistence of stars in this cluster. When we talk about a population of stars, we mean a group of stars that share common characteristics, such as age or chemical composition. Just as people of the same age may share experiences or cultural references, stars of similar populations can provide a collective narrative about their origin and evolution. Understanding these populations in clusters like NGC 1755 gives astronomers a chance to have a front row seat to the grand theater of stellar evolution. Star clusters are like time capsules that preserve the histories of stars past, present, and future. Given the proximity to our own Milky Way, these star clusters stand as excellent cosmic classrooms for the purpose of exploring and learning in this vast universe. NGC 55 and its luminous stars stand as storytellers who, through their past, present, and future histories, provide us with a constantly evolving view, demonstrating that there is always more to discover, even in the tiniest sprinkling of stars. Image number 4. A stellar dance among galaxies. In the vastness of space, galaxies are not isolated entities. Sometimes they come so close together that they begin a cosmic dance, influencing each other due to the gravitational forces that hold them together. This phenomenon is vividly illustrated in the image of ARP 273, a pair of galaxies located at a distance of 300 million light-years in the Andromeda Galaxy. The larger galaxy of this duo has a peculiar distorted and contorted silhouette, as if someone had left footprints in the sand. In the case of ARP 273, the smaller galaxy ventured so close to its larger companion that it passed directly through it. You can imagine two cosmic entities so immense and powerful that one goes right through the heart of the other. What happens when two galaxies intersect in this way? Imagine throwing a pebble into a calm pond and the ripples propagating outward. This is similar to the gravitational perturbations caused in the larger galaxy by the smaller galaxy. This phenomenon is known as a tidal interaction, where the gravity of a smaller body, such as the smaller galaxy in ARP 273, influences a larger body, reshaping it in the process. It is fascinating how even on cosmic scales, entities can influence and modify each other's shape. These interactions offers us insight into the dynamic nature of our universe, where there are still countless evolutionary histories of galaxies waiting to be discovered. Each of these galaxies' interaction events unravels a little more of the vast tapestry of celestial tales waiting to be told in the universe. Image number 5. Deciphering the heart of our galaxy. As we venture into the heart of our galaxy, the Milky Way, we encounter an infrared mosaic that defies our ordinary perception. This intricate infrared composite image unfolds the central core of our galaxy, revealing secrets previously hidden from our eyes. The mosaic is a fusion of colors representing different temperatures and elements, illuminating a region that spans more than 300 light years. Why is this part of our galaxy so significant? In these cosmic confines, a new population of massive stars is found. And these are no ordinary stars. They are titans that harbor immense energy and exert a profound influence on their environment. What has this vivid picture revealed? The interactions and behaviors observed in this central region provides crucial clues to scientists about the birth and tumultuous interactions of massive stars. Imagine being able to peer into the inner workings of nature's stellar factories from our cosmic vantage point. But this awe is not limited to just the Milky Way, as this infrared image offers a window into a local laboratory. When astronomers look at the fiery central regions of distant galaxies, they can compare their observations to what they witness at the center of the Milky Way. This helps them draw conclusions and theories about how massive stars form and how they often come to an end in dramatic explosion in galaxies far, far away. Located about 25,000 light years away from us in the constellation Sagittarius, this center is not simply a dot in space. It is a testament to the dynamism and complexity of galaxies. With each new observation, especially those as detailed as this one, we come ever closer to unraveling the mysteries of our universe. Imagine the wonders that could be lurking in the heart of the Milky Way, waiting to be revealed. We hope these stunning images from the James Webb Space Telescope mesmerize you as much as they do us. Which of these images captivated you the most, and why? Share your opinions in the comments box, and if you have a passion for the wonders of the cosmos, let me know by liking the video and subscribing, and see you in the next video.